Hi and welcome to this video where I'm going to start with a general introduction to the standard AS 91392, Demonstrate Understanding of Equilibrium Principles in Aqueous Systems. This standard is generally referred to by teachers as aqueous chemistry. This standard follows on from the level 2 NCEA standard on chemical reactivity, and as you can see from the title, really focuses on what's happening in aqueous systems. Now, what I really want to talk about here is just some general principles. This is a very mathematical standard, and perhaps more importantly, in terms of that math, there are 4 basic equations. You get given them in your resource sheet. There are lots and lots and lots of variations and shortcuts that you can learn from them. However, I don't recommend using them, and I don't recommend learning them. The reason for that is that when you learn lots of shortcuts, sometimes people focus purely on the shortcuts and not on the reasons behind using the shortcuts. And if you don't understand why you would use a shortcut or where you might use a shortcut, the chances are you're going to use the wrong one in the wrong place. So the approach that I'm going to teach you in this series of videos is to go from first principles. Always start with that basic equation, and then you really have to consider what it is that is going on in your reaction system. So I'm going to draw some really crappy diagrams showing what's happening with the particles in your beaker or flask or whatever it happens to be you're doing, because that's actually what you need to think about. Not which shortcut should I use here, but actually what's happening in the system. Now, this topic in general covers 2 basic parts: solubility equilibria and acid-base equilibria. When we're talking about solubility equilibria, we're talking about sparingly soluble salts. We're talking about calculating the concentration of ions from Ks and vice versa. We're looking at factors that will influence solubility, such as pH, common ions, and the formation of complex ions, the presence of secondary reactions, and all that kind of thing. And we're going to look at how we calculate solubility and or the concentration of dissolved ions in a whole bunch of situations. And then with acid-base equilibria, we're going to look at calculating the pH of strong and weak acids from pH and pKa. We're going to look at what species are present in solution, which is actually essential for the whole lot of that part of the topic. We'll look at what happens during an acid-base titration, buffer solutions, and the use of indicators in titrations and what that actually means. Okay, now this is all about equilibrium, so a very, very brief recap from year 12. First off, we need to think about what equilibrium reactions are and identifying them, equilibrium constants, and factors that affect equilibria. Okay, these are the most important things that you need to know in this topic. Okay, so remember that equilibrium reactions are reversible. Okay, so they have that funny wee arrow that goes in 2 directions. You can actually find it in your keyboard. It's called rightwards harpoon over leftwards harpoon. Just for fun. Much easier to hand draw it, I promise you. Now, what is an equilibrium reaction? It's a reversible reaction, and equilibrium is achieved when the rate of the forward reaction and the rate of the reverse reaction are equal. Now, the concentrations will not be equal, but the reactants will be forming products at the same rate that the products are forming reactants. So the concentrations will at that point remain stable. We use an equilibrium constant, Kc, to identify whether the reaction is at equilibrium and whether the forward or the reverse reactions are favoured at that point. Now, equilibrium constant is going to become a really big thing in this topic because we use the equilibrium constant Ks for solubility equilibria, and Ka and Kb for acid and base equilibria, and of course Kw for the water equilibrium. Okay, those are basically the only 4 equations that I want you to memorize how to do in this standard. Everything else will come back to one of those 4 reactions or equations, Ks, Ka, Kb, and Kw. Oh, and the equation that calculates pH from H2O+. But we'll cover those when we get to them. But seriously, with just minimal equations, you can solve any problem in this standard, but you have to think about what's happening in that system the whole way through. All right, enough about that kind of preamble. I'll see you in the next video where I start talking a little bit about solubility. Bye.